Good morning. So in continuation of previous video, there I explained what is interrupt, what is the difference between polling method and interrupt method, how many interrupts are there, and the program flows. So in this video, I'm going to explain steps on interrupts and how the interrupts are occurred, different interrupts are occurred. So here, steps on interrupts is, the first step is, so when the interrupt occurs, normal execution put on hold. Normal execution put on hold. Then save the return address in PC, I mean address of the next instruction, that will be saved in the stack. So automatically it performs push operation. And PC is loaded with the interrupt address, I mean interrupt vector address. After that, execution start. Interrupt service routine or interrupt handling subroutine is executed. And at the end of the ASR with the instruction RETI, restores the return address back to PC by RETI instruction. And normal execution starts. From here it was interrupted. So these are the steps to be, steps occurs or events occurs when the interrupt occurred. Now we'll see what is timer flag interrupt, when it is occurs, what happens when the interrupt occurs, and what about the flag clearance, whether it is automatic or not, how it is automatic. So timer flag interrupt occurs whenever timer bar counter overflows. That means when it overflows, the corresponding timer flag TF0 for timer 0 or TF1 for timer 1 is set to 1. When it's set to 1, interrupt occur. So flag is cleared to 0 when the resulting interrupt generates a program call to the appropriate timer subroutine in memory. I mean, whenever it is it generates a program call, immediately the flag will be cleared. And serial port interrupt. So when a data byte is received, an interrupt bit RI becomes 1. Receive interrupt becomes 1. When the data byte is transmitted, an interrupt bit TI becomes 1. So these are all together, performs OR operation to provide a single interrupt to the processor, that is called serial port interrupt. That means either RI is equal to 1 or TI is equal to 1, serial interrupt will be occurred. So the programmer must clear TI or RI in the service routine to enable the next data communication operation. And then external interrupt. So we have pins INT0 and INT1 are used for external circuit. External circuit, output of the external circuit is connected to these pin, either INT0 or INT1. So these can be edge triggered or level triggered. So based on the status of ITX, bit of a TCON register. So suppose if it is ITX means X can be either 0 or 1. IT0 for interrupt 0, IT1 for interrupt 1. If it is 1, that IT pin is called as external interrupt signal control bit. If it is 1, it performs edge triggering. That means the flag will be IEX is set to 1, IE0 or IE1 is set to 1 whenever INT X can be 0 or 1 is 1 to 0 transition, means falling edge. Even the falling edge occurs, interrupt IX will be equal to 1. Suppose when ITX is equal to 0, so IEX set to 1 when ITX receives a 0, that is level triggering. So external interrupt occurred. In this case, whenever IEX is equal to 1, external interrupt occurred and processor performs hardware call to interrupt service routine automatically. And flags IEX will be reset when the processor vectors to ISR. And if it is level triggering, the low level signal should be removed by the programmer before execution of RETI instruction. Otherwise, interrupt will be occur again and again. So reset means whenever reset occurs, it is a non-maskable interrupt. That means we cannot ignore it. So as I said, some of the interrupts can be ignored, but it is non-maskable, cannot be ignored. And when it occurs, uh, whenever RST pin is equal to 1 and jumps to the address 000H. So the program pointer is not stored for later resumption because so program will not come back. So all interrupts except reset are under the control of program. Except reset are all are under the control of program. It can be ignored, it can be masked. The program can block all or any combination of interrupt by suitably setting or clearing the bits in the following SFR. That means to say the interrupts can be blocked, or some of the interrupts can be blocked using an SFR or special function register. That means special function registers associated with the interrupts are interrupt enabled register IE and interrupt priority register IP. And timer control register, as you know, lower 4 bits are assigned for interrupt flag. Now we'll see interrupt enable register. So this is the status of register. So from D7 it is EA enable all, and D6 is reserved enable timer 2 interrupt, enable ES means enable serial interrupt, enable timer 1 interrupt, enable external interrupt 1, enable timer 0 interrupt, enable external 0 interrupt. So A means enable or disable all interrupt. Whenever it is 0, no interrupt is acknowledged. I mean all are disabled. Whenever it is 1, so then each interrupt is individually enabled or disabled by setting or clearing the enable bit. So enable ET2 means enable or disable timer 2 overflow interrupt. It is for 8052, not for 8051. Enable or disable serial port interrupt, enable or disable timer 1 overflow interrupt, enable or disable external interrupt 1, external timer 0 overflow interrupt, external interrupt 0. Okay. So if it is 1, enable, if it is 0, disabled. This is about IE register. Now we'll see IP register. So as I said, so priorities can be assigned to the interrupt. So that priority will be set by IP registers. So this is the status of IP register. From D7, 2 bits are reserved. Next D5, PT2 timer overflow interrupt bit, interrupt priority bit, serial port interrupt priority bit, timer 1 overflow interrupt priority bit, external interrupt priority bit, timer 0 overflow interrupt priority bit, external interrupt 0 priority bit. If it is 1, high priority. If it is 0, low priority. Okay. This is how we can set high priority or low priority. I mean only 2 priority levels can be set. Suppose interrupt on interrupt priority upon the reset. That means whenever the reset occurs, the priority list will be from highest to lowest. First highest is external interrupt 0, timer 0, external interrupt 1, timer 1, serial communication. This is the priority level. At last, timer 2 interrupt. Now the question is, say suppose if external hardware interrupt 0 and 1 are activated at the same time. I mean 2 interrupts are activated at the same time. Interrupt external hardware interrupt 0 and 1 at the same time. External interrupt 0 is responded first because so both are same priority level. INT 0, INT 1 both are same priority level. If both occur at the same time, then it follows default priority list. So under that, so external interrupt 0 will be serviced first and then external interrupt 1 will be serviced. Now we'll see programming timer interrupt with an example. Write a program using interrupts to get the data from P1 and send it to P2 while timer 1 is turning on and off the LED connected to P0.4 every second. That means here 2 tasks are there. One is get the data from P1, and send it to P2. One task. Another task is timer 1 turning on and off the LED which is connected to the pin P0.4 for every second. So 2 tasks are there. So we'll do getting the data from P1 and send it to P2 in the main program, and for other program turning on and off will generate an LED, interrupt. Whenever the 1 second is over, so we'll generate interrupt, we'll make it on, After that, we'll come back and we'll do the main program action, that is getting the data from P1 and turn it to P2. After 1 second, again generate the interrupt and it will make off like that. So first we'll see delay calculation for 1 second delay. In the question they have not specified the crystal frequency, so we'll assume crystal frequency 22 megahertz. Then timer frequency is, that is divided by 12, so 1.833 megahertz. So timer period is 1 divided by 1.833 megahertz, so that is equal to 0.546 microsecond. So with this values to be loaded for 1 second. If maximum possible delay with the initial value 00 is 65,536 into 0.546 microsecond, so that is equal to 35.75 millisecond. So if it is get multiplied by 28, if it is multiplied by that 28, it is approximately equal to 1 second. So use the timer 1 interrupt. To enable the timer 1 interrupt, the value to be loaded into here registers here. First we should enable this. So this is 1 and this is all 0 0, and we should enable timer 1 interrupt. So this is 1, the remaining are 0 0. So in hexadecimal it is I is equal to 88H. So this is the preliminary requirements. So in the next video I'll explain the program.